And then for suffixes, they can suffixes, it's determined by the highest priority functional group in the carbon chain. So after you identify the carbon chain, if it's just an alkane, just hydrocarbons with only single bonds, then you just add an ane at the end as a suffix. For alkenes, anything with a double bond in the chain, you add the ene at the end. And then for alkynes, the chain has a triple bond. You add ine at the end. Sorry, hold on one. Sorry about that. Yeah, so those are for the hydrocarbons, single, double, and triple bonds. And then if the highest priority functional group is an alcohol in the chain, you can name it by replacing the E in the alkane name with OL. So instead of methane, it would be like methanol, ethane would be ethanol. And then you would number the carbon attached to the hydroxyl group with the lowest possible number. That's to signify that the alcohol group is the highest priority functional group. So you would specify it with, you would assign it the lowest number possible. And they can also name it by having the alkyl group and then followed by the word alcohol. So for ethanol, it could also be called ethyl alcohol. On the bottom, I just have some common alcohols that you might see. So methanol or methyl alcohol, ethyl alcohol, which is also ethanol, propanol or propyl alcohol, and then isopropyl alcohol, that's less common. And then for molecules with multiple alcohol groups, so for diols or glycols, they have 3 alcohol groups. You can use the suffix diol instead. So this is any alcohols with 2 hydroxy groups. When they have 2, you have to still specify where the position of both the alcohols are. You have to number the hydroxy groups. So for example, for an ethane with 2 alcohols, you would name it ethane 1,2 diol. So you number where the 2 alcohol groups are, the 2 hydroxy groups are in the alcohol. So the first one would be at carbon number 1 and then carbon number 2, and then you add diol at the end to specify that there's 2 alcohol groups in this parent chain. And then when the highest priority functional group is an aldehyde, it's a carbonyl at the end of a carbon chain. I put the structure on the right to show you. So since it's usually attached to, since it's at the end of a carbon, usually it's attached to C1 because if there's no other higher priority functional group, then it's the highest priority functional group. So then since at the end of a carbon chain, you usually number that carbon 1, and then go upwards when naming the other carbon. So the carbon next to it would be carbon 2. So this R group, the next carbon would be carbon 2, and then 3, and then 4, so on. And when it's at carbon 1, usually they don't number it because they just assume that it's at the first carbon. So for methane with an aldehyde group attached to it, it would be called methanol. Ethane would be ethanol, and then propane would be propanol. So that's for aldehydes. For ketones, the carbonyl is in the middle of the carbon group, right? So you have to number that. You have to specify which carbon it's on. So when you assign the number to the carbonyl carbon, you have to identify that in the complete name of the group. And when it's the highest priority functional group, you have to replace the parent alkane. You have to replace the E in the parent alkane with the suffix "-one". So instead of like ethanol, it would be it would be, you would need a propane. So instead of propane, it would be propanone. And so ketones, they'll have the alkyl groups attached on either side of the carbonyl carbon, and you have to list those also. So you usually list the alkyl groups in alphabetical order, followed by ketone. So if it has like ethane and then a methane attached to it, you have to specify that in the name, and then just add ketone as a suffix. And then next, carboxylic acids. That's usually on the first carbon, and they're pretty oxidized since the carbon has 3 bonds to oxygen. So it's usually the highest priority functional group in the molecule. And to name the carboxylic acid, you take the parent alkane name and replace the E at the end, and you add the suffix oic acid to it. So instead of methane, it would be methanoic acid, ethane, ethanoic acid, propane, propanoic acid. And on the right is just the structure of the carboxylic acid, the basic general structure of it. And then ester, so those are usually created by reactions with carboxylic acid and an alcohol. You take the alkyl name of the esterifying group, so usually the alcohol, and then you usually replace the oic in the name of the parent acid with OA. So if it's a, let's say, methane attacking this carboxylic acid to create this ester, you would call it methane, methyl, and then whatever acid it is, methyl propanoic acid, if it was propanoic acid attacked by a methanol. And then on the general, on the right is just the general structure of an ester group. So you can see on the left side is the structure of a, on the left half of this molecule is the structure of a carboxylic acid, and then on the right is the structure of an alcohol group, And when those two react with each other, they create this ester molecule. Next, I'm going to go over amides. So for amides, when you want to name it, you have to replace the suffix with amide. And then, as you can see on this picture on the right, the nitrogen usually has two R groups attached to it. You have to name those as substituents for the nitrogen atom. So you have to label it with a capital N to specify that it's bonded to the parent molecule via the nitrogen. So don't confuse that with the lowercase n that signifies a normal straight chain for the alkane. So the capital N means that it's the substituents are bonded to the nitrogen atom via the nitrogen. The substituents are bonded to the nitrogen atom, and that's how they're connected to the whole parent chain. And usually you don't number the substituents because they're attached to the nitrogen, so they wouldn't have a number since it's not bonded to a carbon. And lastly, anhydrides. So these are created by reactions of 2 carboxylic acids. So to name it, you have to replace the suffix acid of the carboxylic acid with anhydride. When there's only one type of carboxylic acid, you can just replace the acid with anhydride. So if it was propanoic acid, you could just call it propanoic anhydride. But as you can see here, these two carboxylic acids, before they form, they have R groups attached to it. So if the R groups are not the same, if the anhydride is not symmetrical, then you have to name both carboxylic acids in the name. So that's for anhydrides. Yeah, so in order to have the complete name, you begin with the name of the substituents in alphabetical order with the number of the carbon that the substituents are on. And usually the substituents are named in alphabetical order, but if they have a prefix like di, tri, tetra, n, or tert, those are ignored when alphabetizing. But when the prefix is actually part of the name, so any non-hyphenated roots that are part of the name, like iso, neo, cyclo, you have to consider those when alphabetizing the substituents. And then the numbers of the carbon they're on are separated by commas, and then separated from the substituent name using hyphens. And then next you add the name of the carbon backbone chain, and then you finish off by including the suffix of the functional group with the highest priority. So this is how you get the complete, this is just like the general instructions for figuring out the complete name if you're given a molecule. So just an example, in this molecule, after you find out the longest carbon chain in the molecule, you use that for the name of the parent chain. So this 8 carbon chain is the longest chain in this molecule. So it would be octane in this name. And then you see the substituents branching off from the carbon chain. You have the numbers of those two. So you would start with carbon number 1 on the left side because it would assign these carbons with the substituents a lower number than if you started numbering from the right side. So on carbon number 3, there's 2 methyl groups. On carbon number 4, there's an isopropyl group. Carbon number 4, it's an ethyl group. And then on carbon number 5, it's an isopropyl group. So those are the substituents branching off from the carbon chain, and you have to list them in alphabetical order. So ethyl, isopropyl, and then you don't consider the di, so it would be methyl. So you can see here, even though it says dimethyl, which is before ethyl and isopropyl, if we were considering the di prefix, but for any prefix like di, tri, tetra, we don't consider it when alphabetizing. So we would consider the M in methyl when alphabetizing. So you can see here you have 4 hyphen ethyl to signify that ethyl is on carbon number 4, the isopropyl is on carbon number 5, and then there are dimethyl, so 2 methyl groups on and they're both on carbon 3. So you write 3, 3 to show that there's 2 methyl groups on carbon number 3.